Okay, use separation of variables to find b of t. So that's like the little help I put in Canvas about when do we use the SASE method. They're asking us to. Separation of variables is the only method we use with SASE, so that's same thing. We're starting with this, and we're finding this. So we're going from a rate to an amount. Because the rate contains the output variable, we have to use the SASE method. So dv dt equals (1/5) parenthesis 100 minus b we always multiply dt across first, so we're going to get dv equals 1/5. I don't like fractions. We can get rid of the 1/5 by simply multiplying both sides by 5. So I'm going to do that. I'm also going to divide both sides by the 100 minus b. So that will give me 5 over 100 minus b dv equals dt. If I get to the green statement, I get 1 point for separating the variables correctly. So now I need to find the antiderivative of both sides. 5 is a multiplying constant, so it can come out of the antiderivative of both sides. This problem has a little trick to it. It's minus 1 times b. Therefore, this antiderivative in blue is going to require the expanded ln rule, where a is -1 and b is 100 for the expanded rule. On the other side here, we just have the antiderivative of 1 dt, which will just be t. So the antiderivative is going to be 1/a, that's 1 over -1, natural log, absolute value, ax plus b. You don't have to write it as -1b plus 100. You can write b minus 100. Just trying to emphasize how to properly use that expanded ln rule. The antiderivative of 1 dt is just 1 t, or you can just write t plus the constant. So if I have the correct statement here in red, that's 1 more point. So we're going to copy this over so we can keep working. And let's get rid of a bunch of this. Well, that's a new feature. So my eraser is a little harder to see precisely what I'm erasing, but that actually works a little better than the old style. Kind of like that. Let's see how the move works. That didn't work. I don't think I can move it. So to find C, I'm going to use the equation here in red. Just start working with it. So I have negative. Oops, gotta get the pen back. So I have -1 natural log, absolute value. B is going to be 20 when time is 0. So this will be -20 plus 100 must equal when time is 0. So I figured out C because Negative 20 plus 100 is 80. Absolute value of 80 is just 80. So C is equal to negative natural log of 80. You don't have to do anything else. You can just leave it like that. And I actually made a mistake that I just recognized. On the previous page, I lost the 5. So unfortunately, that would cause me to lose all the points on this problem. So be careful not to lose the 5. The 5 was a multiplying constant, which meant this numerator right here had to have been 5. So back here, this is negative 5. So this is negative 5 times the natural log of 80 is my value for C. If I get that far, I have used the initial conditions on this line right here, and then I used those initial conditions to find C correctly. So all of this red is worth 2 points. Then I go back to this equation. There's a 5 here, by the way. That's terrible. I go back to this equation. So we'll copy that over again to get some space. Erase this. And we solve the equation. So we have negative 5. Natural log. Absolute value. Negative b plus 100. Equals t minus c, which was minus 5 ln of 80. Some people have been mentioning they struggle sometimes to get the test done on time. Make a note somewhere that this last step often takes the most time. So if you're looking for a place to skip, that's a good place to stop, go do some other things. If you have time, come back to it. But I've never seen them give more than 1 point for that isolate step. So if you can't get to that, I would just do other things first. That's virtually guaranteed. Okay, so to get the b alone, I have to get the negative 5 to the other side. So that means I'm going to have natural log, absolute value, minus b plus 100 must equal all of this divided by 5. So that will be t minus 5 natural log of 80 all over negative 5. I don't have to do any simplification. Dividing those 5s is not legal because the 5 in the numerator is not a factor of the numerator. Okay, to get rid of the ln, I use this formula right here. So I take and make both sides an exponent of e. So I'm going to have e to the natural log, absolute value, negative b, plus 100 is equal to e to that big mess. This problem gets messy, but you don't have to clean it up. You can just leave it messy. Just keep using paper. Okay, e to the natural log of something is just something. So now what I have is, I can get rid of this now. Okay, so I have the natural log, absolute value, negative b plus 100, oops, absolute value, equals this mass, e t, subtract 5, natural log 80, all divided by negative 5. To get rid of the, oh, sorry, no natural log, just absolute value. The board is definitely distracting for me. Okay, to get rid of absolute value is kind of like getting rid of a square root. You consider that the answer could be two possible answers. Either what's inside the absolute value here is what you see here, or what's inside the absolute value is the negative of what you see here. One of the two. So we're going to copy this over, just because my board runs out of space. And we're working on this piece here in blue. So the two possible answers are negative b plus 100 is equal to, well, once we move the 100 over, it's going to subtract, so let's save a little writing here. So this will be negative b equals e to the t minus 5 natural log of 80. All of that is divided by negative 5. And that is then, because the 100 subtracts over, that would be minus 100. Or, to get rid of the absolute value bars, this piece must have been negative. So one possible answer is you multiply both sides of this by negative 1, and you get b is equal to 100 minus this big thing. And then you check to see if that gives us the right value when we plug in t equals 0. So we put a 0 in for t right here. We would get 0 minus 5 ln of 80. So that time the negative 5s would divide. E to the ln of 80 is going to be just 80. 100 minus 80 is 20. That works. So when you plug in time equals 0, we get the right weight. If we had taken the other approach, which was to count this as negative here, it would not have worked. That's the one point. That's why I say skipping that isolate step is a really good choice if you're trying to save some time.